Right, so questions from our notes then. Question 3.12, we have find where the function is increasing. Now, if we're looking to find where something is increasing, straight away, I know we're talking about our slope. Where is our slope greater than 0? So what we need to do is get our first differentiate, because first differentiate is slope, and find where our slope is greater than 0. So for this, I'm going to get my first differentiate out of our function here, and our first differentiate is going to be 3x squared plus 10x plus 8. I'm trying to find where that is greater than 0 because it's increasing. If it was decreasing, then I wouldn't need to do greater than 0, I would just do less than 0. So from here then, to solve something like this, I use my minus b formula. And when I fill in my minus b formula, I'm getting minus 2 and I'm getting minus 4 over 3. From here, because I can see that this has a less than symbol, what I need to make sure I do, so there's my less than symbol there. What I need to make sure I do is I make sure I graph it out. Now this is a quadratic, even though the original function was a cubic, what we are graphing out is the quadratic that we got the values from. And for this one, I can see here that they're both going to be on the left hand side. I have a minus 2 and a minus 4 over 3. It doesn't need to be massively accurate. And there's my graph. And what I'm checking to see is it's greater than 0. So I'm looking for greater than 0. I'm going to shade this in and shade this in. And so I'm checking to see, am I going to the left or to the right of that minus 2? I'm going to the left of that minus 2. So what I have here is I have x's less than minus 2. I'm going then with the minus 4 over 3, I'm going to the right of minus 4 over 3. So that's going to be greater than minus 4 over 3. So my two answers are going to be x is less than minus 2 and x is greater than minus 4 over 3. And there's my full finished answer then. So anytime it's greater than or less than, you must add that little section in at the very end. Our second question then, now if it's ever saying show that it's increasing, what we're going to end up doing is we're going to end up, again, if it's increasing, we're looking to find that the slope is greater than or equal to 0, which means our first differentiate is greater than or equal to 0. We're talking about getting the first differentiate and showing that there's no way it can be negative. So chances are we're going to need to know things here like anything squared will be positive. So with something like this, be careful you're differentiating. Here we need to use u and v because it's a fraction. U is going to be x. The differentiate of u is going to be 1. V is going to be 1 minus x to the power of 4. The differentiate of v in terms of x is going to be minus 4 x to the power of 3. And I fill in my formula. Be careful with the formula, make sure you're using the right one, because for the differentiate, for the quotient rule, which is what this is because it's a fraction, it's v du. So it's going to be v du dx minus u dv dx all over v squared. With this, we never need to multiply at the bottom, but we do need to multiply at the top. So I'm going to multiply both of these by 1. And I'll end up with 1 minus x to the power of 4. The minus by the minus is going to cancel and give us a plus 4x to the power of 4. And that's just by multiplying that x by the x to the power of 3. All over, and I'm keeping the bottom the same because I don't need to square it out. Tidying it up once more, I have 1 plus 3x to the power of 4 all over 1 minus x to the power of 4 squared. And I'm trying to prove that that's always greater than 0. So if it's always greater than 0, what I can say is x to the power of 4 is greater than 0, and then anything squared is greater than 0. Therefore, I'll have a plus over a plus, which is greater than 0. And there's my answer there. So last little step, I would always say as well, therefore, it's increasing.